All right, so the next part of integers that I think is really important and sometimes really confusing for people is what we call the counting methods. This question usually comes at a very high level. So if you see this question usually like at 155 already, 150 up to 160 type of question. So if you see this question, you're probably like doing really well. So but it's also important to know them so that in case they come in these other section 1 here of maths, you should also be very, very careful to be able to solve them. So the question says, so counting method. So in your counting, always check for the number of possible values in each position. Always check for the number of possible values for each position. So let's do a few examples so I can be able to understand what I mean. So example 1 here says, how many 3-digit integers are there in which no number appears more than once? A bit of a thinker there. 1 minute. Let's try and solve it. Are you able to solve this question? How many 3-digit integers are there in which no number appears more than once? How many 3-digit integers are there in which no number appears more than once? 1 minute. 1 minute. Let's try. This is a 1 minute question. I'm only going to give you 1 minute to try and solve this one. This should not take you more than a minute. Again, the instruction says always check for the number of possible values in each position, right? So 1 minute. Let's try it. Let me see some answers in the chat. Some people, let's see if anyone is able to get that. Seeing a raised hand. All right, 1 minute. We're counting down the seconds. Thirty more seconds, 30 more seconds. All right, 10 more seconds. 57. Doug is saying 57. Thank you for that trial, Doug. So Doug, why do you think it's 57? Why do you think it's 57?
I think it is 57 because the question is how many 3-digit integers are there. So in 457, the first 3-digit integer that I see is 400. The second one is 41.
These are just an example here.
43.
Doug.
Yeah.
This is an example. Sorry, this is an example here. I hope we don't confuse this. This is an example. Like they're giving an example for this. How many are there in which no numbers appears more than once? Example is 457, meaning it's going to be something like 2, 3, 4, meaning no number will appear more than once here. So nice try.
Oh, not specifically for 457.
Yeah, this is just an example of what it would look like.
Okay, my bad.
No, it's okay. Daniel is saying. Daniel Mutuku is telling me the answer is 9. Daniel, why do you think it's 9?
I'm not quite sure, but I was doing my calculation as 1, 2, 3, 2, 3, 4, 3, 4, 5, and then up to 9. So I thought it was up to 9. There are 9 occurrences, but if one takes, for example, 4, 5, 7, then there is an issue.
Okay, so let's see. Let me help you do that, and then you can try out the second one with whatever I teach you. So how many 3-digit integers are there in which no number appear more than 1? So 3-digit integers. I want you to draw line number 1, line number 2 there, and then line number 3. Just do that, and then now we'll check out. For this is the first x. This is the first integer. The x, y, and then z. All right. So these are the integers here, and then Ian is saying 504. Okay. Let's keep the trials coming. So this one, how many 3 digits? So for this first one, x here, x is like the one at the very end here. So it's going to be xyz. That integer, let's say that integer is xyz. That's the 3-digit integer here. So for the first x here, how many values can go into x here? So you can only pick from 0 to 9, right? Like that's like, it has to be one integer. You can't have something like 12 here and then have something like 5 here and then have something like 6, because it can be 1256. So it's going to be only one value. It's going to be one value, and it's going to be one value, meaning it's going to be values between 0 and 9, right? So, but you're being told there are 3 digits. So if you had something like 0, 1, 2, this is just 12. So it's not like a 3-digit integer, right? If you had 0, 1, 3, this is just 13. So meaning in X here, X can't be 0. So can't be 0 here, meaning here it could be between 1 and 9, right? So you have between 1 and 9. X could be anything between 1 and 9. Now for Y here, you can have a value, for example, like 402, 403, right? So here you can have between 0 and 9, right? And then here you can also have between 0 and 9, because we have a number like 450, for example. We have a number like 340, for example, meaning 0 can enter into the last number, right? You can have a number like 402, so it can be anything between 0 and 9. Here it can be anything between 1 and 9, anything between 0 and 9. That's the first thing to remember. Then the second thing is you're told no number appears more than once. So for example, if 9 was the answer for X here, if X was 9, meaning 9 can't appear here. So we've already removed 9 as an option here. So the only options you have is from 0 to 8. So how many options are these? These are still 9. So because 0, 1, 2, 3, 4, 5, 6, 7, 8. So those are 9 options you still have there. Then Z, you have 0 to 9 can enter here, but you already have taken 9 out of this, right? Because let's say 9, you've picked one number here. So you've already removed one option. So you have 0 to 8 left. Then you've already removed another one option here. So you have 0 to 7 left here. So meaning 8 numbers is what can like be placed in this. So you have the first blank can be 9, the second blank can be 9, the other blank can be 8. What you simply do is just multiply these 3 numbers, which is just 81 times 8. It's going to give you 89 times 8 is going to give you 8, because 81, 8 is 8, and then 64 times 8. So the correct option here is 658. Anyone got that? Manja Alphonse was able to figure that out very quickly. Very nice. So I hope that has been very clear. If you have a question, please ask. If you have not understood anything, please ask. Please ask. Right? Let's do the second question here. We have question 2 here. How many positive integers are there below 1000 that have no odd digits? How many positive integers are there below 1000 that have no odd digits? How many integers are there? Or how many positive integers? How many positive integers are there below 1000 that have no odd digits? This is an interesting question. This is an interesting question. Are we able to figure it out? We've used an example like what I've taught you here. Let me give you a minute. Let's try it out. Let's try it out. Thirty more seconds. 30 more seconds. Twenty more seconds. 20 more seconds. Needs to see some answers in the chat. Nobody? 10 more seconds. We have a trial. 9 times 9 times 4. Aha, very nice. Yeah. 9 times 9 times 4. Aha, that's a good idea. 4 times 5 times 5, 100. Wow, okay, Vincent, that's nice. $100, Richard. So let's do it together. Again, how many positive integers are there below 1000? Again, so Below 1,000, let's say, well, Shadrach Oking is saying 100, Richard Moore is saying 100. Okay, so meaning below 1,000, meaning it can be 3 and it can be 2, right? It can be 3 and it can be 2. So anything from 0 to 999 can be an option here. So you can have like one digits, you can have 2 digits, you can have 3 digits, you can have up to 3 digits. So it can be either be 1, 2. So for example, 2 is an even number that is, it's a positive integer that is, that have no odd digits. So 2 is an even integer that has no odd digits, right? 4, again, 624, 42. You see this, there's no odd here. Yeah, so anything below 999 can be an answer, right? So 4 by 4 by 4, 73. Alphonse is asking. So anything below 1,000 can be an answer, meaning that means 0 can be an option here, right? 0 can be an option. 0 can be an option here. 0 can also be an option here. 0 can also be an option here. So let's try it out. So here you have X, you have Y, you have Z. Same thing. So how many positive integers are there? So X can only be 1. It can only be a single digit. So it can either be 0, it can either be 2, it can either be 4, it can either be 6, it can either be 8, because it has to be only even. There are no odd digits, so it has to be even. So it can either be 2, it can't be 1, it can't be 3, it can be 4, it can't be 5, it can be 6, it can't be 7 because 7 is an odd, it can be 8, right? So 1, 2, 3, 4, 5. So here you have 5 options. You have 5 options here. So 0, 2, 4, 6, 8. Again, you have not been told that they are not repeating. Here you are told no number appears more than 1. So here you have not been told that they can't repeat. So 22 is an option, all right? 600, 500, let's see. 666 is also an option. You have not been told that it can't repeat. So again, here you can have 0, you can have 2, you can have 4, you can have 6, you can have 8. Same thing here. You can have 2, 0, 2, 4, 6, and you can have 8 here, right? So you have 1, 2, 3, 4, 5. So you have some option. 5 times 5 times 5 here. 124 Shadrach. So here you have 5. What just happened? Sorry. So Y can also be 5, meaning it can be 0, or it can be 2, it can be 4, it can be 6, or it can be 8. I hope that's clear to everyone. So it can be 1, 2, 3, 4, 5. So you have 5 options here. And then also 1, 2, 3, 4, 5. You also have 5 options here. So you have 5 times 5 times 5. 125. But you've been asked how many positive integers. You remember we said 0 is not a positive integer. So if you had 0 here and 0 here and 0 here, 0, 0, 0 is not positive. So you see, you use 0 as an option, you use 0 as an option, you use 0 as an option. So 0, 0, 0 is not a positive integer. So you just come and subtract 1 here. This gives you 124. So please, if you have any questions, these questions you'll find they're always tested. They're always tested in the GRE because they are really good for tricking people who are not very careful with how they're reading the question and answer. So if you have any question on how we are solving this, please raise your hand and then ask. Please raise your hand and then ask before we move on to the next. So let's do this last example together because of time, and then we move on to the next topic. I see we have about 30 minutes left. Let's clear some space here. So the question reads, what is the total number of 4-digit palindrome? What is the total number of 4-digit palindrome? A palindrome is an integer that reads the same forward and backward. So 3, 4, 4, 3 is an example. This is an example. So if you have 5, 4, 4, 5, this is also an example. So what's the total number of 4-digit palindrome? So that of course, if it's 4 digits, meaning already you have 1, 2, 3, 4 here. So 4 digits, meaning 0 cannot be an option here. You can't have like 0. If you have 0 here, this is going to be a 3-digit palindrome. So it has to be 4. So meaning the only option you have is between 1 and 9 here. You can have 1 and 9 here. So it could be anything 1 to 9. So let's say, for example, it's 9, right? That's your first option. Let's say it's 9. So the second one here, you also have 1 to 9, right? You can also pick 1 to 9 because it can be 9, 9, 9, 9. 4 nines is 9, 9, 9, 9. Reads the same buckets and 4. So here, let's say it's 8. So if you have 9, you have 8 here. What options, how many options do you have here and here? Because when you read this answer here forward, it also has to be the same backwards, meaning this also has to be a 9, this has to be an 8. Meaning for this place, you only have one option, and for this one, you also have only one option. Right? I hope everyone is able to get that. So if you have 9, 8, for example, let's say that's your first 2 number. You don't have any other option but to do 8, 9. So the first blank here, if it's X, Y, Z, A. So if you have X, Y, Z, A, Y and Z have to be equal. X and A have to be equal so that it can be a palindrome, meaning this number and this number have to be equal, this number and this number have to be equal. So you can have 9 and then you can have 1 to 9 here, you can have 1 to 9 here. So you have 9 options here. This is what? Sorry, this is 10 options, not 9. 1 to 9. Yeah, this is 9. So here, the second one, sorry. Well, this is what I meant. This one is 0 to 9, right? Because it can be 9, 0. Someone is on mute. Yes, Manje. Yeah, that's what I was pointing out. Can we please mute Sharon? Okay. So you have an option like 9009, meaning the second here so 9009, you can read the same forward and backward. So option 1 here has to be 1 to 9, meaning it can be something like 9. Option 2 here is 0 to 9, meaning it can be 10 options. And then for this last one, you only have one option and one option here. That makes 10 times 9, gives you 90, which is option B. So I hope this is just some of the examples. You can, of course, go and do so many more practices on these types of questions. You always just have to figure out like how many numbers can I plug in that particular position, right? I hope we're okay with that. The next thing that we're going to be covering, or the next topic that we're going to be covering in terms of integers, is the fractions. So maybe if anyone has a question on integers, do you have any question on integers? You feel like something was not covered clearly, you'd like me to repeat? Let me see some thumbs up if we're okay so far. Are we okay so far? I'm seeing 2 thumbs up. Nice, Richard. Thank you. All right. So I see most of us are okay. I'm seeing some thumbs up. I hope we're all following. If you have a question, please feel free to just unmute and then ask. So for fraction skills, when we're talking about fractions, you can substitute values in a fraction to quickly find the answers. You can substitute values in a fraction to quickly find the answer. So a proper fraction does not need to be in the simplest form unless asked directly. So what this means, if you have a fraction like 5/10 in the GRE, you've done your maths, you've gotten 5/10. You don't have to do 1/2. This can always be an answer here. You'll always probably even find that 5/10 is an answer. 2/4 is an answer. 10/20, you'll find it's an answer. So in the GRE, you don't need to find like the simplest form of a fraction unless they ask you directly like to find the simplest form of that fraction. So let's do a few examples to see what I mean. So you can substitute a value. So if you wanted to do this fraction very quickly, so you have the numerator 3/4 minus 1/5, and then you have the denominator 3/4 plus 2/3. So how would I solve this? So this is how usually to solve your very quickly. This is what you do. For the denominators, multiply them, then have this as an equal. Multiply these denominators, have that as a 20. Then do what we call cross multiplication here. So because the GRE doesn't expect you to do the fraction in its simplest form, you can always do cross multiplication. Meaning for 5, bring it here. Always remember the sign, keep the sign the way it is. So for 5, bring it here, multiply by 5. And then for 4, bring it up here. multiply by 4. So what's 3 times 5? 3 times 5 is 15 minus 4 times 1 is 4. So it's 15 minus 4, which gives 11 over 20. The same thing for the denominator, 3 over 4. You don't need to find like the simplest form. So 2 over 3. Again, to do it, multiply these ones. 4 times 3 gives you 12. And then do cross multiplication here. Always give put your sign there. So this one will multiply by 3. Then the 4 up there. So 3 times 3. Basically, it's 3 times 3. It's 9. And then 4 times 2. So the inverse of that. So cross multiply. Multiply this one with this one. Multiply that one with that one. So 4 times 2 is 8. This gives what? 17 over 20. So you have 17 over 12. 17 over 12. So you have 11 over 20 divided by 17 over 12, which is equals to 11 over 20 times 12 over 17. So of course you can always find that very quickly. 11 times 12 is, I believe, is 132. That's 132. And then over 17 times 20. 340. So yeah, something like that basically. So always, you can always cross multiply that, and then always, let's do the second example here. You have a half minus that. So multiply the denominators. So this one, even though you are seeing it can be an even number, you can always divide that. You don't need to simplify. You can always leave this. This is always going to give you a correct answer. So again, multiply 2 and 3 gives you 6. Then you do 3 here, you do 2 here, which is multiply. It gives you 3 minus 2 gives you 1 over 6. Then the same thing, a half plus a third, 6, and then 3 plus 2 gives you 5 over 6. So 1 over 6 divided by 5 over 6 is the same as 1 over 6 times 6 over 5. This gives you, you can do this 6161, 1 over 5, or 6 over 30, whichever way you feel like works for you. So I hope you're able to see that. So this is how usually you solve the GRE fractions very quickly. You don't have to really like take a lot of time trying to figure out what's the LCM, what's this, what's that. Just do the cross multiply and then multiply the denominators and then have your sign in the middle there and then do all that. It's going to give you your answer very, very quickly. All right, I hope we are good with that.
You are watching Success with Bob Mwiti Show, presented to you by Upstech America. Upstech America is a consulting company that helps immigrants find amazing higher education and job opportunities in the tech industry in the United States. You can find our programs by going to www.upstechamerica.com. Upstech America, we wake you up to the unlimited potential.
So in the GRE, we have what we call word diffraction question. So you'll find like a fraction question that is very, very long. You have like this one, for example, it's a very long question and it's asking about fractions. But the secret is if we know the remaining fraction, then we know the existing fraction. If you're able to figure out the remaining fraction, then you will automatically figure out the existing fraction very simply. Let's take, for example, this first example here. 15 students in a class finished the math test on time. And the remaining, again, we have the remaining fraction. 2 over 7 of the students in the class finished the test late. How many students finished the test in total? So the remaining 2 over 7 of the students, meaning 1 over 7, 5 over 7, and then 2 over 7. So this is the remaining. So meaning this is existing. So you are being told 5 over 7 is equals to 15 students. So 15 students finished the maths on time, and the remaining 2 over 7, meaning 2 over 7 was out of left, meaning the people who finished are 5 over 7. So very quickly you can do 5 over 7 is equals to 15. What about how many students finished the test in total? So all of them, 7 over 7. So you can have 7 over 7 times 15 divided by 5 over 7. This is 1. So 15 times 7 over 5. 5, 1, 5, 3, this gives you 21. All right, so if you're able to figure out the remaining, if you have the remaining fraction, then it's going to be very easy for you to figure out what is the existing fraction. Let's do another example here. I'm trying to rush a little bit because of time. So if you're not understanding anything, please feel free to ask. So the second one, 2/3 of the vegetables in a bag are damaged. If 8 vegetables in the bags are undamaged, how many vegetables were thrown away if 3/4 of the damaged are thrown away? Right, so they've done a little of a twist here at the end. So if you're not careful, you might fail this question because of the twist. How many vegetables would be thrown away if 3/4 of the damaged are thrown away? So meaning we have first to find the damaged vegetables. So you are being told 2/3 of the vegetables are damaged, meaning what's left are third. These one are undamaged. And you're being told if 8 of the vegetables are undamaged, meaning the undamaged are third, these ones are 8, right? So how many of them are damaged? So what about 2/3? This is 2/3 times 8 divided by 1/3. This gives you 2/3 times 8 times 3/1. This gives you is equals to 16. 16 of them are damaged. So this one is 16 vegetables. So how many vegetables will be thrown away if 3/4 of the damaged are thrown away? So you are being told 3/4 of the damage. So 3/4 of the damaged, which is 16, is what are thrown away. By 4, 1. By 4, you have 4. So this gives you 12. So that gives you 12 thrown away. So again, if you're able to figure out the remaining fraction, then knowing the existing fraction is going to be very simple for you. This question is a free mark for you in the GRE. Whenever you come across this question, automatically gets your free mark. So I would like us to try this last. I need to see some answers for this last one here. If 6 is x quarters of 16 and x is a fifth of y, what is y? If 6 is x quarters of 16 and x is a fifth of y, what is y? I'm going to give you a minute to do that. Very simple question. One minute to do that. We have 1 minute. Let's see some answers in the chats. 15/2. Interesting. Manja is saying 15/2. That's an interesting take. Any other options? Let's get two more people trying it out. If 6 is x quarters of 16 and x is a fifth of y, what is y? Ian, 15/2. Very nice. Anyone else? Let's see. Let's get two more. Let me see a lady answering. Faith, very nice. 15/2. So I see we are getting the gist of it. So if we usually when you say here x quarters, if you talk about 3/4 of something, 30/4, yeah, that's also an option. Very nice, Faith. You don't have to simplify this. So let's go through it. So if x quarters of 16. So if you talk about 3/4, you say 3/4. 2/4, 2/4. So x quarters will be what? x/4. So if 6 is x quarters of 16, so x quarters of 16 is equals to 6, right? So let's find x here. So 6. So of course is, just get me some space here to write. So we are saying x quarters of. So x/4, x is x quarters of 16 is equals to 6. So this is basically 16x/4 is equals to 6. This gives you, multiplied by 4 here, multiplied by 4. This gives you 16x is equals to 16x is equals to 6 times 4 divided by 16 divided by 16. 6 times 4 here is 24/16. Right, so x is equals to 24 over 16. And x is a fifth of y. So x is a fifth of y. So 1 over 5 y is equals to x. So 1 over 5 y is equals to 24 over 16 times 5 over 1 times 5 over 1. This gives you y is equals to 24 times 5 over 16. So the people who got 15 over 2 or 30 over 4 are of course correct. So you don't have to spend a lot of your time trying to find like the simplest form of these answers. So just go with the closest calculation you can think about. The easiest one for you is what, just go work with that, and then the GRE will always give you the answer for the most of those answers there. So you don't have to substitute, but yeah. So when it comes to fraction, always try and find the remaining fraction. This is going to help you find the existing fractions. The other really important, so that's it on fractions. There are so much more to cover, but we don't have the time to cover everything. But of course, we have a topic called fractions on the Manhattan 5-pound book. I need you to go at least and do at least 10 of those questions, do at least 15, depending on your time. Try out different fraction questions, see how you're able to cover all those questions there. So the next subtopic you're going to be talking about, we're able to go through this first topic very quickly because they are relatively simple things we're able to understand. So exponents. So exponents are what we always call powers. When you hear exponents, they're just powers. So if you talk about 3 power 4, this is the exponent or power. And then this 4 here, we call the base here. So exponents are just basically power. So some exponents that you need to memorize when you're going to sit the GRE. This one, there's no option for you. Squares. This one, when we were in high school, we were able to understand from 1 to 15. If someone asks you the square of 13, are you able to quickly figure out what the square of 13 was? The square of 12. Are you able to very quickly figure out this value? So between 1 to 15, the squares for those ones are not an option. You should not be getting your calculator to find what the square of 14 is, what the square of 15 is. You should be able to very quickly figure out 1 to 15. Some people even know 1 to 25, right? So always try and 1 to 15 have that locked in your memory. I don't know if you go and remind yourself, go and get the powers book, the multiplication book that we had in the back of the covers back those days. But yeah, so try and remember the squares from 1 to 15. So basically 1 squared, 2 squared, 3 squared, all the way to 15 squared. These ones, you just have to remember them. You can't be using your GRE time in the calculator, wasting your time trying to find these squares options here. Another really important square to remember is 2 power 6 is 64. 2 power 10 is 1024. Basically, the squares of 10 are usually like relatively easy to remember. You're able to very quickly figure it out because it's just whatever. So for example, 512 here will be 2 power 9, right? So 3 cubed is 27. Some people confuse this. I've found myself confusing 3 cubed so many times. 3 cubed is 27. That's one to remember. 5 cubed, 125. And then 4 cubed is 64. So 2 power 6 and 4 cubed are usually the same thing because it's just 2 squared and then 3. This is equals to 2 power 6, right? So these are just some of the squares you need to remember. 4 cubed, 5 cubed, 3 cubed, 2 power 10, 2 power 6. These one are the most common. This, maybe I should say that's why you know why I'm telling you it's important. Most common. 90% of the time in the GRE when they're asking about powers, you'll find they revolve around something that revolves around this. So they are most commonly used. So another thing to know about the exponents part is when negative numbers are raised to even exponents, they become positive. So negative 2 squared is equals to 4, right? So negative 3 squared is equals to 9. So if a negative number is raised to an even exponent, so this is a negative number, it's been raised to an even exponent, they become positive. If they are raised to an odd exponent, negative 2 cubed, this will still be negative 8 here. So if they are raised to an odd exponent, so always check the exponent here. If they are raised to an odd exponent, they remain negative. So that's something to note, and you'll see why it's important to note them. Brackets matter in exponents. So brackets matter. Where are the brackets placed? So if, for example, negative 3 squared and negative 3 squared, these are two different things. This is not the same thing in the GRE. So if you are told -3 into bracket squared and then -3 squared, the answer for this one is 9. And then the answer for this one is -9. You see, because the negative has not been enclosed in any square bracket. So for the GRE, this is really very important. They use this to trick you. So brackets matter when it comes to exponent, right? So let's look at an example that we have here for the exponent. So if you saw this question in the GRE, will you like immediately go and get a calculator? I know some of us will immediately go and try and see if they can be able to find this in a calculator. This, even if you had a calculator, is going to take you just such a long time. It's really not worth like doing this in a calculator. So how depending on what I've just explained here, how will I solve this question in the GRE? So you see, this one is -5 power 4. This is an even exponent, meaning it's going to be positive, right? -5 power 4. It's an even exponent. So when negative numbers are raised to an even exponent, they become positive. So whatever the answer is here, it's going to be a positive. And then this is a negative number raised to an odd exponent. So this is going to be negative here. And then this is a negative number raised to an even exponent. So this is going to be positive. Then we have a negative number raised to another even. It's going to be another positive, and then negative number raised to odd. So this is going to be negative. So you have negative and negative. So negative times negative is equals to positive. So these negatives are going to cancel themselves out. So whatever answer you're going to have here is going to be a positive number, and it's obviously going to be a very big number. So this number here is going to be greater than 1 either way, because this is a very big number. So very quickly you can be able to say quantity A is greater. So you see, knowing this information has saved me a ton of time, a lot of time here trying to figure out like, oh, what is -5 power 4, what is, and then multiplying them. Just knowing that when a negative number is raised to an even exponent, it becomes positive, is going to save you in so many places. You don't have to do this. Again, the GRE is a lot of tricks, so you don't have to do most of this multiplication. Just remember those really important tricks and components, right? So I hope that is clear. Let me see them thumbs up. I know I might be alone in this class. I've spoken too much. I've been speaking continuously. Are we okay so far? Are we following together? Let me see. I'm seeing some people are asleep. Some people are not giving me thumbs up. Are you lost? Maybe. So we can try and find you. Amos, nice. Okay. Amos is telling me he's okay. All right. So, all right. I'm seeing most of us are doing well. So let's carry on. So of course, if you remember these questions are going to be so easy for you. So easy for you. Just try and figure out like, if this is a negative number, does it become negative? Does it become positive? And try and multiply. So you see, I've not done any of these maths here, but I've been able to very quickly figure out the answer there. All right. So what are the rules of exponents? So exponents have rules and laws that you need to remember. If you are writing it down, I will suggest you write this down. These ones are going to save you a lot of time if you remember them. So the first rule is called the product rule. A power m times a power n is equals to a power m plus n. This basically means, for example, 2 power 2 times 2 power 3 is equals to 2 power 2 plus 3, right? So this is just equal to 2 power 5. You don't have to like do all that math. So X product rule, when you're multiplying exponents, you just add their powers. When you're multiplying exponents, just add their powers. That's why initially when we were saying 10 power 2 times 10 power 3, that gives you 10 power 5 here, because it's 100 here, and then it's 1000 here. So it is 1, 2, 3, 4, 5. So you see 1, 3, 4, 5. So that's why when you have the same base, notice this, the base have to be equal. You can't come and say 2 power 3 times 3 power 2 is equals to something like 6 power 3 plus 2. This is not correct. You can't do this. The base have to be the same. So everything here is when the base, for product rule, is when the base is equal. So this one here has to be equal to each other. And usually you'll find, and you'll come to see, like, there's always a way to make these bases equal. There's always a way in the GRE. That's something I really like about the GRE. There's always a way to find and to make these bases equal. We'll be able to see that. The next one is the quotient rule. When the bases are equal, a power m divided by a power n is equals to a. So we did this. 10 power 8 divided by 10 power 5 is equals to 10 power 3. Why? 10 power 8 time divided by 10 power 5 is equals to 10. 8 minus 5. So you just subtract that, gives you 3. So that's called the quotient rule. Quotient rule, when the bases are the same, again, you can't say like 10 power 8 divided by 5 power 5. Then you say that this is 2 power 3. No, this is not correct. The base have to be equal. This base here. So 2 power 10 divided by 2 power 8 is equals to 2 power 2 there. All right, so that's called the quotient rule. Then we have something called power of power rule. Power of power rule. So if you have 2 power 3 squared, this one is going to give you 2, 3 times 2. Just multiply those two powers together. If they are both in brackets like this, multiply the powers together. So again, really important for the GRE that you note this down. The next one is called the power of product, meaning A power B power M. Again, notice they are both in the brackets. Brackets is very important for exponents. So if they are both in brackets, this is A power M, B power M. This one is going to save you. Actually, I've seen it save so many times, like the amount of time you can be able to do. If you're able to figure out this very quickly, you can be able to cover most of this question. The same thing, power of quotient. Again, if it's if it's 2 times 3 power 3, this is the same as 2 power 3 times 3 power 3. The same thing for the power of the division. A over B power M is equals to A power M over B power M. You can be able to break out. But again, notice the brackets are very important. If this was not in brackets, you will not be able to do this. Zero exponent rule. So for the zero exponent rule, basically any number power 0, any number power 0 is 1. Even if it's 10 billion, power 0, it's always going to be 1. Any number power 0 is always going to be 1. So if you raise any number power 0, it's going to give you 1. The next rule, again, it's really important to remember negative exponent rule. So if you have A2 power negative 2, this is equals to the same as 1 over 2 squared. Right? So the negative 2 makes it into a fraction. So it's just going to be 1 over 2 squared. And then we have something called finally fractional exponent rule. So A m power n is equal to, for example, 2 over 2 thirds. This is equals to the 3 comes here, it becomes a cube root, and then 2 squared. So this is called fractional exponent rule. So very important. Again, these are the 1, 2, 3, 4, 5, 6, 7, 8, about 8 very important rules when it comes to the GRE. All right, let's see if you're able to use those rules to factorize very quickly. So rules of exponents allows you to solve equations quickly by prime factorizing the base. So if you're given a question like this, 20 power 7, and then you have 4 power 13 over 4 power 6, 5 power 4 times 5 power 3, this is 5 power 4 times 5 power 3 here, so that we don't confuse. So if you see this, some people already will start freaking out, like, how do I do this? Do I get the calculator? But once you remember 20 power 7 here, 20 power 7 is what? It's 4 times 5. This gives you 20. So power 7. So, and then we have 4 power that, or 4 over 13, 4 power 13 over 4 power 6. We remember we said if it's over, this is going to be 4 13 minus 6. So it's giving you 4 power 7. Because this is the division, you subtract the powers. For division, when they're in brackets like this, subtract the powers. And then 5 power 4 times 5 power 3, if it's multiplication, you add the powers. You add the powers, so 5 power 7. So times 5 power 7. So we said if you open the bracket here, you said if it's A times B power M, this is equals to A power M times B power M. So 4 times 5 power 7 is going to be 4 power 7 times 5 power 7. And this is again 4 times power 7 times 5 power 7. So you see, it's going to take you 15 seconds to do these questions when you remember the rules of exponents. If you remember those rules of exponents, you're able to figure out these questions very quickly, and then you're able to solve them very quickly. So again, we see we have something like 2 power 2 squared times 420, and then 2 power 5 times 105. You'll find someone going and getting the calculator and trying to figure out like what this is. Without realizing 420, if you look at 420 here, is there a way? Usually try and find, is there a way like 420 is divisible by 105? I'm pretty sure if they give you something like this, usually like something that is almost divisible. So if you see 420 is what? 105 times 4 is going to give you 420 here. So if you're able to figure out for 20 times squared there, 25 and then 105, doing the like terms, 4 is what? 4 is 2 squared. Again, this is why we are saying you should remember the squares here. So this is going to be 2 squared into bracket 2 squared times 105. So you have 2 times 2 squared times 105. So join the brackets here. It's going to give you 2 power 4, 105, and then it's giving 2 power 5, 105. So again, because you know the power of exponents and you know how exponents work, you're able to figure out that quantity B is greater very quickly. I can see we are coming up on time, but allow me to just finish these exponents and then we can end from there and then we can start at roots next time. I think this is the last part for exponents. Yes, I believe so. So this is the last thing about exponents, and then next time we can begin with roots and then go ahead with that. So for digits, there's usually something called digit streaks. So for exponents, when you're doing exponents, there's something called digit streaks, right? So every single digit from 0 to 9 goes in a certain cycle when raised to a power. So whenever we raise anything to a power, so they will always go in a cycle. For example, the cycle repeats. Usually the cycle repeats after 1, 2, or 4 times, never more. So the maximum number of times the cycle can repeat is 4. Numbers that have 0, 1, 5, or 6 will always be in a cycle of 1. 4, 9 will always be in a cycle of 2. So what do I mean by this? If you have 2 power 1, this is 2. 2 power 2, 4. 2 power 3, 8. 2 power 4, 16. 2 power 5. We only want to see the ones, the units value. The units value is what we care about. It's 32, ignore the 3. 2 power 6, 64. So 2 power 7, something that ends with an 8. So you see, after 4, it repeats, it starts repeating. The units digits become equal. So the units digit will always go in a cycle. When you're powering any number between 0 and 9, when you start powering them, they'll always go in a digits of 0. So if it's 6, for example, 6 squared is 36. The next number is going to give you something that ends with 6. And then the next number, something that ends with 6. So 4 and 9 will always be in a cycle of 2, meaning 16 is going to be 6 and then something like that. So they are going to repeat themselves. Let's see in an actual example. So you have been asked, 3 power 33 ends with what? You can't take a calculator in the GRE and do this 3 power 33 like this. You just have to figure out like what is the cycle for 33. So if I say 3 power 1, this is 3. 3 power 2, this is 9. 3 power 3, 27. So I only care about the units digit. And then 3 power 4 is 3 4 times is, I believe, 81, because 27 times 3. So 3 power 4 is equals to 81. Again, I only care about the units. So, and then 3 power 5, 3 power 5. So I've already hit 1, 2, 3, 4. So it's never going to be more than 4. So whatever is going to be here is going to repeat itself. So 3 squared, 3 power 5 is 3. 3 power 6 is going to be something that ends with 9. Of course, you can confirm this with your calculator. Trying doing 3 6 times there, you'll find something that ends with 9. 3 power 7 is going to be something that ends with 7. And then 3 power 8 is going to be something that ends with 1. So 3 repeats in a cycle of 4. Repeats in cycle of 4. So after 4 powers, it's going to start repeating, like the units digit is going to start repeating itself. Right? So let's look at this. You've gotten 4, 8, meaning the next here it's going to be 16. It's going to give you something that ends with 1. And then after 16, so find the closest that ends with 33. So 32, right? 32 is a factor of 4. So 32 is going to end with 1. So after it gets to so this means this is 31. 3 power 31. This is 3 power 32, by the way. 3 power 31 is going to be something that ends with a 7. So meaning 3 power 33 is going to be something that ends with a 3. You see? So with this, I don't have to do this multiplication here with a calculator. I just go and check my answers, which answer ends with a 3. With that, I'm going to be able to very quickly solve that. So let's look at another example here. What is 39 times 64? I have answers here. 24, 96, 25, 44, 24, 60. Do I go and open my calculator, waste those 15 seconds trying to do this? No. What do I do as someone who's known the units digit? So the units is going to be 9 times 4 is going to be something that ends with 6, because 9 times 4 is 36. So it's going to be something that ends with a 6, carry something. So, and if you see from the option here, only one of them ends with a 6. So within 10 seconds, 5 seconds, you're able to figure out like 24, 96 is the answer. So it's always going to repeat. Basically, the units, whenever you power a number, the unit is always going to, the units digit is always going to repeat itself. Let's look at our last example. 16 power 16 and then 17 power 17. Of course, you can always try, if one thing like this, you can always try and open your calculator, see 16 squared, what is 16 squared? It's going to be 256. So 6. It's always going to be something that ends with a 6, basically. We have said for 6, it's always ending something that ends with a 6. You can try this out. Try and find what 16 power 3. Try to find what 16 power 4 is going to be an answer, because it's always going to be 16 times 6, then something times 6, which is always going to be 36. So it's always going to be 6, 6, 6, like that, repeated. For 17, you can do the first few. You can't do 17 power 17, but you can do the first few. So 17 here is 17, and then 17 squared is 289. So again, I just need the 9. I don't care about these other ones. 17 cubed is what? Is going to be something that ends with a 3. It's going to be 4913. Yes, so something that ends with a 3, and then 17 power 4. It starts, and then 17 power 4 is going to be something that ends with a 1. And then 17 power 5 is going to repeat. So if you get to the end here, always know, if you see that it's repeated up to the 4 times, when it gets to the 4th time, it's always going to repeat itself again. So it's never been, the units digit is never going to like repeat itself after the 5th time. It's not going to not give you a new number. So the cycle repeats after 4 times. So if you see you have not been able to get the cycle the first time or the second time, always go all the way up to 4. I always recommend going all the way up to 4. And then whatever you find in 4, that is your cycle. So 7, 9, 3, and then 1, like that. So meaning whatever is going to be 17 power 5 here, it's going to end with 7. You can try that out again with your calculator. 17 power 6 is going to be something that ends with a 9. 17 power 7 is going to be something that ends with a 3. And then, so this is going to be 4, and then the next one is going to be 6, going to get up to 16 down here. 16 gets down here. So the meaning the next 17 is going to be here, because this is 4, 8, and then 16 here. So the way it repeats, the cycle repeats after 4, 4, 4, 4. So number 16 and then number 17. So meaning number 17 is going to be something that ends with a 7 for me. So if I'm told what is the remainder of 16 power 16 divided by 7, I know it's going to be a number that ends with a 6 multiplied by a number that ends with a 7. 6 times 7 is 42. So it's going to end with something that ends with a 2 and then a very long number here. So what is 22 divided by 2? What's the remainder? It's going to be 20 remainder 2. What is 32 divided by 2? Remainder 2. What is 42 divided by 2? Remainder 2. It's always going to have, if our numbers are 2 at the end, the remainder is always going to be 2. So very quickly, I'm able to figure out that the remainder is 2 without doing this very long multiplication process. So I hope we're clear with that.